Welcome back. Well, as we've kind of progressed forward from talking about sequences and series and looking at arithmetic and geometric sequences, we're now going to take a look at exponential functions. Now, exponential functions, we've looked at linear functions. We know linear functions, they have a constant rate of change as we look at that. And we know that they can be written in the form y equals mx plus b. And we've looked at quadratic functions, and those are y equals ax squared plus bx plus c. And we know that those are parabolic in shape. They're shaped like a parabola, and they've got a vertex, a maximum, a minimum, things like that. Well, we're going to look at exponential functions now. So an exponential function is any function that can be written in the form y equals a times b raised to the x power. Or you could say it's f of x equals a times b to the x power. Well, a couple of things here. First of all, a cannot be 0. A cannot be 0. So when we look at these, a cannot be 0 in an exponential function for it to be exponential. And secondly, the b has to be greater than 0. Okay, so b is always going to be something that's greater than 0. Okay, so it's greater than 0, and lots of rules, I know. B cannot equal 1. Well, the reason for that is because if b is 1, anything raised to the x power isn't going to matter. It's always going to be 1. So if b were 1, it would be linear. Okay, so these are the rules, and we turn around and we look at them. Now, notice a couple of things here. First of all, we've got to notice that the b is a constant. Okay, so b is going to be a constant. B is some number. That doesn't mean it's always a whole number, but it's a number. So b is a number, and our exponent is a variable up here. So we're raising to an exponent, we're raising to a variable's power. So our power is a variable. So this is an exponential function, y equals a times b to the x. So let's take a look at a couple of these, and we'll start from there. So let's just take y equals 1 times 3 to the x power. Or we could just say y equals 3 to the x power, because we know anything times 1 is just that number. So the a in this case is 1, the b is 3, and we're raising it to the x power. So let's just make us a table of values over here, and let's find some values, and let's go ahead and look at this and see what it looks like. Well, if we plugged in -1 to y, if we plugged in -1 here, so that'd be y equals 3 to the -1 power. Well, remember our rules of exponents. Anything raised to a negative power is the same thing as 1 over it, so y would be 1/3. Okay, well, what about if x is 0? Well, 3 raised to the 0 power. Rules of exponents, anything raised to the 0 power is simply 1. All right, well, 1. 3 raised to the first power would just be 3. 2. 3 to the second power is 3 squared. Well, that's 9. Third power. 3 raised to the third power, 3 cubed is 27. If we were to take it at 4, 3 raised to the fourth power, that would be 81. Okay, well, some crazy numbers here. Let's turn around and let's look at these, and let's graph a couple of these. So there's -1, there's 1, 2, 3, 4, 5. Let's just go ahead and pick some numbers here. There's 1, 2, 3, 4, 5, 6, 7, 8. And we'll go ahead and squeeze a 9 in here. Okay, so if we go ahead and we start to plot this, let me change colors real quick. Let's change to a red. At -1, we're at 1/3. So when x is -1, we're at 1/3. Well, that's somewhere up here. Okay. At 0, when x is 0, we're at 1. Okay. When x is 1, we're at 3. So 1, 1, 2, 3. At 2, we're at 9. At 2, we're way up here at 9. Okay, well, this thing's off the chart. Well, I wonder what would happen. What if we pick something like, I don't know, like -4? What if we did -4? Well, that would be y equals 3 to the -4 power. Ooh, rules of exponents. That would be y equals 1 over 3 to the 4th power. Well, 3 to the 4th power is 81, so that would be 1 over 81. The crazy thing about this is, what you're going to find is it's never going to get here across In this case, it's never going to cross this x-axis. Okay, so what we have here is we have this invisible barrier that it's never going to cross. If you remember back when we've talked about that before, we call that invisible barrier, that line that we cannot cross. We can get ever so close to, but can't cross. It's called an asymptote. So asymptote. So in this case, that x-axis is our horizontal asymptote. That's our line that we're going to get ever so close to, but never going to cross over. Now, if you remember from before, that asymptote can change. It can be moved up or down, but for right now, this invisible barrier that we will never cross this x-axis is right here. So it's an asymptote. So this is the kind of the idea of an exponential function. It has this kind of curved shape, and I know we've looked at them before, but here's what it looks like and what we need to be able to turn around and plot these in. Now, when we talk about exponential functions, there are two ideas for exponential functions, okay? We have what's called exponential growth. And we need a dividing line between us. And we have exponential decay. Exponential decay. Well, if we look at these two kind of root words right here, we look at growth and we look at decay. If we look at growth, when we look at decay and you look at, okay, well, what do those words mean? Well, growth means it's going up. It means it's increasing. So an exponential growth equation is going to be anything that's written as y equals a times b to the x, where our b term here, and b has to be greater than 1. Okay, that makes it grow. So if our b term is greater than 1, it doesn't matter what a is, but our b term has to be greater than 1. That's going to cause it to turn around and grow. And an exponential growth one is one just like we looked at before. It's going to turn around and it's going to be going up. Okay, so this one is exponentially growing. Now, a decay one is one where we write in the formula y equals a times b to the x. However, b, when we look at the b, remember we said before, when we talked about the b, we said that the b has to be greater than 0, but it can't be equal to 1. So in this case, b is greater than 1 when it's a growth. Well, for an exponential decay problem, what we have is 0, the b has to be between 0 and 1. So it's a number less than 1, but it's greater than 0. Can it be 0? No. Can it be 1? No. But any number in there. So if you look at it as any decimal, any fraction between 0 and 1, 1/8, 1/4, 0.25, 0.86, 4/5, 8/9, anything in there, any decimal, any fraction that you could turn around and come up with between these, that would be an exponential growth, or an exponential decay, sorry. And an exponential decay, when you look at it, when we graph it, it will look something like this. Okay, why? Because it's decreasing. As we look at it from left to right, it goes down. It's decreasing. So, couple of examples to them. What would one look like that's exponential growth if we're turning around and looking at it? So, if I gave you something like, oh, I don't know, c equals, let's go 179 times 1.029 raised to the x power. Well, notice here, when we look at it, when we're examining whether it's a growth or decay, we look at this number right here. We look at the b term. That's how we tell, even without graphing, we can look at that. Look at that number, 1.029. Is that greater than 1? Yes, it's greater than 1. So this one is exponentially growing. This is exponentially growing. It's increasing. Versus one that would be an exponential decay, and something very similar to this one. What if we had said c equals 179 times 0 0.47 to the x power. When we look at this one, when we examine it, we look at our b term. We look at our b term right here, and we see, hey, that b term is less than 1. It's a number between 0 and 1. So that tells us this is a decay problem. Okay, so it's a decay. It's important for us to be able to distinguish between these and know whether we have something that's increasing or whether it is decreasing when we start it. So this is kind of the intro to exponential growth, exponential decay to exponential functions. So remember, anything we can write in the form y equals a times b to the x power, where b has to be greater than 0, but b can't equal 1, and a cannot be 0. So as long as it meets those qualifications, and we look at it, it's going to kind of have that sort of L shape. It's either increasing or it's decreasing. So we're going to look at these functions when you get back to class. We're going to be graphing lots of those, so make sure you have taken these notes. If you've got questions, we're going to turn around and we're going to put them on a calculator and go through there. All right, good luck, and we'll see you later.